Welcome to briavel Institute. Now we're discussing the force of interest. This topics is coming under the actuarial mathematics, cm1. So cm1 we divide into 5 module. 5 module is there. Each module have the 40 classes. So total 200 classes is available. So visit our www.briavelinstitute.com and register. Online registration is there. After registration, subscription option is there. So subscribe. You can subscribe module wise, class wise, and entire course also. So anybody is interested, you can visit the www.briavelinstitute.com. Now we can discuss the what is the force of interest. So in last 7 class in this chapter, interest rate chapter, we studied the what is the nominal rate of interest. So nominal rate of interest is representing I raised to p. So it is compounding or converting p3 pthly. So what is the meaning of ip? P times is compounding in a year, in a period. So p times is compounding. So what is the I raised to 4? So 4 times in a year. I raised to 2 means it is a 2 times in a year. 2 times in a year, it is compounding 2 times. So it will be a half yearly. So I raised to 6 times compounding. Or I raised to 12 times compounding in a year. That means it is monthly. So this we discussed in last 7 classes. Last 7 class we discussed here. This all nominal rate of interest, nominal rate of discount, and we solved some problems also. Now we are discussing the force of interest. So it is related to the nominal rate of interest. So we can start with some example. This is bank A. So this is a bank A, and this one is one more bank is there. So this is bank B. So time 0 if you are invested in 10,000, and time 1 year is for 1 year. Here also investing in 10,000, time 0 for 1 year. So both bank is offering effective rate of interest I is equal to 5%. Both bank is offering effective rate of interest I is equal to 5%. Now what will happen after end of the 1 year? This is the effective rate of interest. Directly we can multiply. We will get the interest of 10,500. Our fund is becoming 10,500. We are getting the 500 as a interest. So here also it's becoming 10,500. So there is no attraction with this bank has to give more offer, then only will get more customers. So this bank what have done, this instead of effective rate of interest, this is effective rate of interest. Bank is normally will give nominal rate of interest. So this bank is informed we are giving the nominal rate of interest. It is convertible half yearly. Bank is informed like that. It is convertible half yearly. So what happened? This bank is also nominal rate of interest. So this bank also changed their strategy, convertible quarterly. So this told that we are convertible quarterly. This bank is saying that is convertible half yearly. Half yearly means 2 times will get a credit. 2 times. That means in 6 months they will give 1 credit, and another 6 months will get 1 more credit. That is compounding 2 times. Here is quarterly. Quarterly means it is 4 times will get a credit. So 4 times will compound. 3 here 1 time. Here after 6 months 1 compounding, and after 9 months 1 compounding. So 4 compounding will be there in a year. 4 in a year. So how to find out the effective rate of interest? So we have a formula. 1 plus I is equal to 1 plus I is equal to 1 plus I raised to p all divided by p all raised to p. So this is a 1 plus effective this nominal rate of interest is providing 5% per annum. So nominal rate of interest is providing 5%, both are 5% per annum. Only difference, this is convertible half yearly, here it's convertible quarterly. So what is effective rate of interest is giving by this bank? It is equal to 1 plus 0.05 divided by 2 all raised to 2. So p is equal to 2. Here is a 2 times only. So 2 times is compounding. So p is equal to 2. So this I is equal to, so this will get interest rate. I is equal to, I will get, this is 1 plus I will get 1, right? Then I is equal to 5.06. 5.06. So effective interest rate is providing 5.06. Now you see I raised to 2, then effective rate is getting 5.06. Same way here you see 4 times compounding in a 4 times is quarterly. So same formula, 1 plus I is equal to 1 plus I raised to p divided by p all raised to p. So we given 1 plus 0.05 divided by 4 all raised to 4. So I is equal to we received 5.094. So this bank is effectively giving more rate of interest. Now you see this bank is giving effectively more rate of interest. So effective rate is equal to 5.094. This bank is giving more rate of interest. So in competition, people more will deposit in this bank only because is getting the effective rate of interest is 5.094. Here is effective rate of interest is 5.06 because here it is compounding only 2 times. Here is half yearly compounding. Here is quarterly compounding. So that once is interest is compounded here, same interest will consider for the next quarters. So this together will consider for the next quarter. So that is a compounding principle. So here is getting, so this bank what happened, this customers and all is going to this bank B. So this bank what have, they have informed that they are reduced to, they are changed to the, their strategy they changed to convertible monthly. Now you see, so competition is increased. So now you see is a monthly. So monthly means convertible monthly. So monthly means 12 times in a credit. 12 times will be compounded. Interest will compound 12 times in a year. 12 times will compound in a year. So we are representing I12. Now see what is the effective interest rate. 1 plus I is equal to 1 plus I raised to p all divided by p all raised to p. 1 we can take this side. So minus 1. So what is the effective rate of interest? I raised to p we can give 0.05. Same. P is equal to 12. Here also it becoming 12. So this is rate is getting 5.116. So 5.116. Now you see increase, rate of interest is increased. Effective rate is increased. When it is convertible monthly, effective rate is increased. So customers will move to this bank. So what happened? Automatically this bank also changed their strategy. So this bank is changed. They are convertible weekly. So they told that is convertible. You can check. So this bank is changed their strategy. What they have done? Is convertible weekly. Now you see it is convertible weekly. So it is a 52 times in a year. Compounding 52 times in a year. I am taking 52 as a 52 weeks in a year. So 52 times compounding in a year. So every week is compounding. So like that it is compounding. So what will be the effective rate of interest? 1 plus I is equal to 1 plus I raised to p divided by p all raised to p. So here 1 is taken to this side minus 1. So I raised to p is equal to 0.05. P is equal to 52 and here it is equal to 52. Now you see rate of interest is getting 5.124. Rate of interest is increased. Here it is 5.116. Here is 5.124. So this bank has to make another strategy. So this bank has done another strategy. So this bank is done daily compounding. So what will happen? You can see it is a convertible daily. This and all of just example. Not like that. It is not there. So just going to understand something. So that is why I am writing here. It is a daily compounding. So daily means 365. I increased it. I is convertible daily means it is a 365 days. So how will get 1 plus I is equal to 1 plus I raised to p divided by p all raised to p. This is taking 1 to that side, 1 minus 1. So I raised to p is equal to 0.05. Here is 365. Here is 365. So we getting the answer of 5.126, almost saturated. Now you see, here is 5.124. Here is 5.126. Now we are coming to this bank, chance of this bank. This bank is saying that we are convertible continuously, convertible continuously. So that is called the force of interest. Now you see, nominal rate of interest is convertible continuously, any point of time, or instantaneously, or any point of time it is convertible continuously in a year, any point of time it is compounding. So what we can call that one? I tends to infinity. That we can say that it is a I tends to infinity, because it is continuous. How many times is there, we don't know. Each time it is, each second it is compounding. So that one we can call as a convertible is continuously. In convertible continuously, this rate of interest I alpha we can write as a delta. This is the force of interest. So now we start with the force of interest. Why we start with the here some example? Here you see, I raised to 2 is a 506. Effective rate of interest is, find out I raised to 4, and I raised to 12, I raised to 52, and I raised 365. Now you see, it is convertible continuously any point of time. So that we can call as a I raised to infinity. So this is not alpha, it is infinity. That is called the delta. This is a delta, that will call the force of interest. Now you got some idea about the force of interest. Means this interest is compounding every time, any minute, any seconds. This is compounding continuously, it is compounding. So in that, the continuous compound is representing I raised to alpha is equal to delta. So how to find out this continuous compounding? So it is a limiting case. We can say that it is a limiting case. So our 1 plus I is equal to, our equation is like that, 1 plus I is equal to 1 plus I raised to p divided by p all raised to p. So here p is equal to infinity. P is equal to infinity, continuous compounding. P is equal to infinity, continuous compounding. So we are giving the limiting case of p tends to infinity. P tends to infinity, 1 plus I raised to p divided by p, I raised to p divided by p all raised to p. So p tends to infinity. So this equation you can compare with the Euler's rule. Euler's rule is saying that limiting case of n tends to infinity, 1 plus x divided by n all raised to n, this is equal to e raised to x. So this is equal to e raised to s. N tends to infinity, 1 plus x divided by n all raised to n, this is equal to e raised to s. So here we can compare, this one we can compare with the here. So 1 plus I is equal to, here this is we can write as a e raised to I infinity. P is equal to infinity, so e raised to I infinity. So 1 plus I will get e raised to I infinity. I infinity we can write it is a delta. So we can write 1 plus I is equal to delta. 1 plus I is equal to e raised to delta, not a delta, e raised to delta. 1 plus I is equal to e raised to delta. So this is the formula for the force of interest. How to find out the delta? Delta is equal to, we can write one more formula for finding out the delta. It is a e raised to delta. So it's an exponential term. We can write that delta is equal to log 1 plus I. So this is where we can find out the force of interest. So what will be the force of interest here? It is convertible continuously. So what will be the force of interest? Now you see what is the force of interest. So force of interest delta is equal to, it is a one effective rate of interest. How to find out effective rate of interest? Effective rate of interest we can find out by using this formula, 1 plus I is equal to e raised to delta. Now we are saying nominal rate of interest 5% is convertible continuously. That means it is a delta. I raised to infinity, that means it is a delta, that is a 5%. So I is equal to e raised to delta minus 1. So we'll get e raised to 0.05 minus 1. So this is a 5.127 percentage. So effective rate of interest is equal to 5.1271 percentage. Now we studied what is the rate of interest of force of interest. We start with the nominal rate of interest. So nominal rate of interest is convertible quarterly, daily, monthly, or half yearly. So its number of times is increasing. Compounding is increasing number of times. Then we can say that its nominal rate of interest is convertible continuously. That is represented by the delta. I raised to infinity is representing delta. That is 1 plus I is equal to e raised to delta. By getting this rule is a limiting case, given the limiting case. So p tends to infinity. So this portion is equal to the e raised to I alpha. So this is Euler's rule. Through the Euler's rule we understood e raised to I alpha. So 1 plus I is equal to this portion you can give delta. 1 plus I is equal to e raised to delta. Delta is equal to log 1 plus I. If effective rate of interest is giving, we can find out the delta. Delta is a force of interest. So force of interest is representing delta. So hope you understood about the force of interest and how to use this force of interest. Now we can check how to use this force of interest. In a bank, we can take some example how to accumulate this value by using the force of interest. So force of interest means it is continuously compounding. So in a bank is invested, person is investor is invested 500 only. In a time 0, invested 500. And force of interest is given, delta is given 8% per annum. So it is a continuously accumulated, continuously convertible and compounding. And what is the compound accumulated value after 3 years? So we can take after 3 years. What is the accumulated value after 3 years? So initially we invested 500. Is the force of interest is 8%. And is after 3 years what is the accumulation? So accumulation, we know that accumulation an is equal to 1 plus I all raised to n. 1 plus I all raised to n. So we have formula 1 plus I is equal to e raised to delta. So I is equal to e raised to delta minus 1. So it is a delta is 8%. So I is equal to e raised to 0.08% minus 1. So this will get 8.387. 8.3287. This is the interest rate for the effective interest rate. Now we find out the effective interest rate. Now we can find out the accumulated value. So 1 plus I all raised to 3 years. After 3 years, this is 1 year, this is 2 years. After 3 years, what is the value? So 1 plus I all raised to 3. So 1 plus I we understood that I is equal to 0.083287 all raised to 3. So we'll get the accumulated value. So we getting the accumulated value is 635.62. So this is after 3 years. 500 is become accumulated to 3 years. 635.62. So this is using the force of interest. Force of interest is given. So we used I is equal to e raised to delta. 1 plus I is equal to e raised to delta. I is equal to e raised to delta minus 1. First we have to find out it should not accumulated value by using the 8%. This is 8% is convertible continuously. So should not use this force of interest directly for finding out the accumulated value. Accumulated value and all is saying that I is a effective rate of interest. So accumulated value is find out by using I only, not a delta. So this is the formula 35.6. This one we can find out like that also. One more method. Another method. an is equal to 1 plus I. An is equal to here is a 3 years is equal to 1 plus I all raised to 3. Or we can write n. N years means it is a n. 1 plus I is equal to e raised to delta. So we can substitute e raised to delta all raised to n. So this is e raised to delta n. So we got one more formula. Accumulation we can use the force of interest by using this formula. This formula it will be useful to find out the effective rate of interest. So here we are using the delta only. In this formula we have to use the I only, we are using I. But in here 1 plus I, instead of 1 plus I we substitute e raised to delta. So here we can directly we can use the delta. Now you see e raised to 0.08 into 3 years. So here we will get the rate of interest. So 500 is multiplying with the e raised to 008.3, and this one also same is 35.62. So 500 is accumulating. So this accumulation, this e raised to delta raised to n. So this is accumulated factor. You can say accumulation factor is a e raised to delta n. So two methods we are studied. First we are force of interest given 8%. We are not using directly delta in the instead of I. So we find out the I, what is the value of I, and we use it here. So we are using the 1 plus I is not a delta. We have to find out the what is the effective rate of interest, then find out the what is the accumulated value. Now we are directly using delta value. Instead of using 1 plus I, we are using delta. Here we are using delta, then we got the same answer. This is 35.62. Same way we can find out the discounting also. So discounting, we know that the discounting is the v raised to vn is equal to 1 plus I all raised to minus n. So that is the vn. So here it is a, we can say that 800 in a discounting, it is a 800 is payable after 5 years. So we have a 5 years of time. So 1 year, 2 year, 3 years, 4 years, 5 years. 5 years 800 is payable. So this is payable. 800 has to pay the after 5 years. So what is the present value? Here is asking about the present value. So we have formula 1 plus I raised to minus n. Or what is the time we can give 1 plus I all raised to t or whatever n. So here is a present, this is a vn. Now normally what we will do? 1 plus I all raised to minus n. How to do vn? So I is equal to I, we can find out by 1 plus I is equal to e raised to delta. I is equal to e raised to delta minus 1. So we got the I is equal to, is the rate of interest is 9%. Here is the force of interest is not 8%, 9%. So 9% is force of interest. So in the second question is we are finding out the discounting value only. So delta is equal to 9% per annum. It is payable after 5 years. 800 is payable after 5 years. Now you see delta is, we know that, so I is equal to e raised to 0.09 minus 1. So we will get the I value. Then what will be vn? Vn is equal to 1 plus I. This I value will get 9.417. We can substitute here. We can substitute 1 plus I 0.09417 all raised to minus 5. 800 is multiplying this minus 5. So we will get the answer to the 510.10. So this is the investment. So we have to invest. So this is a present value. Finding out the present value, it is a 510.10. 510.10 we are depositing here in the time 0 in a force of interest 9% per annum. Force of interest 9% per annum means it is continuously discounting. So continuously compounding. So is after 5 years we will get the 800. So this is 800. This is one more method we can find out directly. Vn is equal to 1 plus I all raised to t. Vt, we are giving the time t. Vt. So 1 plus I minus Vt. So here 1 plus I we can give delta. So delta raised to minus t. So it is equal to e raised to minus delta t. We can multiply like that. So it is, if you are getting the force of interest 9%, we can use the present value. We can find out directly e raised to minus 0.09 5 years. So 800, this is a discounting factor. This is a discounting factor. Discounting factor is finding out by the using this formula. So directly we will get the 510.10. 510.10. So both way we can find out the present value. Here is one method we use it for the, we find out the effective rate of interest, then we discounted it to the, what is the present value, discounting by using the effective rate of interest. Here we are used effective rate of interest. Here you see we use it for the force of interest. Force of interest is minus delta t if you are giving, then directly we will get the present value. So this is a two method, accumulation and discounting. So hope you understood about the force of interest. This force of interest, we have another 6 more class. 6 class is there, and with we'll solve so many problems also. Force of interest and force of function of time, and exam types problems also will be there, that we will solve in the 5th and 6th class. Hope you understood about the force of interest. Once again is saying that kindly subscribe our channel, also register for the online study in our institute, only online study only. So 200 class will be available. Study, register and subscribe that all the classes and study in online. Thank you.